So this is an example of a Canvas system with 8 nodes. When we say nodes, we mean a ECU or a microcontroller. So this is one node, this is 2, 3, 4, 5, 6, 7, 8. So this is a canvas, this orange line. So if this ECU wants to communicate with this ECU, then this ECU will send its data on the canvas. The data will flow through the canvas and finally it will reach this ECU. So how message is sent and how message is received by a controller we'll be discussing in future slides. Let's take one little history lesson. So CAN was first developed by Robert Bosch in Germany in 1986 when they had certain requirements for Mercedes OEM. They found that this point-to-point communication was no longer suitable in this situation. So they needed some other communication method which will make this requirement more efficient. So the first CAN silicon was then fabricated in 1987 by Intel. So what are advantages of a canvas? So far you can also list down certain advantages. So first one is like it is organized and more sophisticated compared to point-to-point communication. As we had seen in point-to-point communication, we need a lot of wires, cables, harness, and it leads to be bulky. But CAN is more organized and more sophisticated. So reduction in weight and cost of wiring looms harnesses. It can handle multiple controllers simultaneously. CAN works in real time. Many real-time applications can be implemented with the help of CAN and can be used in various applications. As we have seen, it is used in multiple industries. So how does a CAN bus works? So we have a bus, we have a microcontroller, we have messages. So there has to be a sending and receiving. There has to be a sender and receiver, and sending and receiving of messages needs to be happen. So a CAN bus system works by sending and receiving messages from node X to Y, or it can be vice versa also, from node Y to X also. What is a node? So a node, it can be a sensor actuator connected to a microcontroller or any other device, example ADC, that helps to turn this assembly into a fully functional standalone unit called as node. There are two types of nodes, transmitter, receiver. So transmitter is a node which originates a message. Receiver is a node which receives that message. So we have two types of nodes, one is transmitter and one is receiver. Next question is, how many CAN bus protocols are there? So basically there are two types of protocol, CAN bus 2.0a and another one is CAN bus 2.0.b. So CAN2 is used with smaller, less complicated systems and CAN2b is used with larger, more complicated systems. So what is this bus protocol? It is a set of rules. So we have two different types of CAN bus protocols. One is CAN2A, one is CAN2B. 2A is used with smaller, less complicated systems. And if the complexity increases and we need more sophisticated protocol, then we make use of CAN bus 2B. Next question is, what is frame? What is message? So heart and soul of CAN bus protocol deals with something called as frame, into which the message to be sent or received on the CAN bus is encoded. So frame is like you can consider it as a letter. And this, you might have this message. So message which is being sent will be encoded or crypted in this frame. So CAN bus deals with frames. And in these frames, something called as message, which is needed by the controller, is being encoded. So now there are two main types of frames in CAN. One is a frame that contains a request for data. Second is a frame that contains the requested data. So here a node will be requesting for data. So that request frame would be sent on the bus. Then there would be another ECU which contains that requested data and that requested data will be again sent in another frame. So the frame that contains a request for a particular data is called as remote transmission request frame. This is also called as RTR frame. Okay, so this frame will contain a request for a particular data. Suppose this ECU wants to know the voltage of another ECU. So it will send one frame, RTR frame on the bus. So this frame will go to this ECU B. This is your bus. And this bus, this frame is traveling. So now this ECU B, it receives the request, and based on the request, it will send another frame on the bus, which will contain the data for this request. Okay. So the frame that contains the requested data is called as data frame. So first one was RTR frame, which contains the request. The second one is data frame, which contains the actual data. So let us consider the frame format for the data frame. So this is your frame. It consists of so many bits. This is SOF, start of frame. This is EOF, end of frame. And it consists of 7 distinct parts, starting from SOF, arbitration field, control field, data field, CRC field, ACK field, EOF, and lastly intermission. This is your RTR. So you can see this also consists of start of frame. It has 6 distinct parts. Data frame consisted of 7 distinct parts. Okay. An RTR frame consists of 6 distinct parts. We'll study in details about all these parameters. Now, a frame, it consists of large number of bits. It would be mostly zeros and ones. So the bits present in a frame are of two types. So a bit can be 0, it can be 1. No way in between. So we have something called as dominant bit and recessive bit. So dominant bit is represented by 0 and recessive bit is represented by 1. So whenever we say 0, it means it is dominant bit, and whenever we say 1, it means it is recessive bit in case of CAN. And one more point that needs to be noted is dominant bit has a higher priority than the recessive bit. So this question is almost asked in interview, which bit have the higher priority? So dominant bit, that is bit 0, have higher priority over bit 1. We shall now discuss each of the 7 parts that make up a frame, starting with SOF. So SOF stands for start of frame. It consists of a single bit. This is the MSB, that is most significant bit present in the frame. This bit is dominant always. So this is always 0. And your frame, your MSB starts from this bit. And next is arbitration field. So this is the most important field for the programmer or system designer. It is also called as the identifier field, as the identity of the entire frame traveling on the bus. So your identity of the message or the frame is present in this arbitration field. So what type of data it contains, what type of a request it is, what type of a frame it is. So all that is decided by the arbitration field. It gives a unique identity to each and individual frame. So this consists of 12 or 32 bit. So next question is, what does arbitration mean and what does identity mean? So starting with arbitration. Arbitration is a process of settling of a dispute between two or more individuals by a third person chosen by them. Let's take an example. Whenever there is a dispute between two people, they go to court and there is a judge who decides. The decision would be in favor of whom? So arbitration is basically a process in which a dispute between two or multiple individuals is settled by a third person, and they only decide who that third person is. So in CAN, this translates into settling of a collision between two or more frames sent onto the bus simultaneously by two or more nodes with the help of CAN protocol, that is the third person. So this is your CAN bus. We have multiple ECUs communicating. So suppose this is your node A, this is node B, and both of them sent message simultaneously. So which message would be given more priority? Which message will be sent on the bus and which message would be discarded? So all those things are decided by this arbitration process. So at a time, only one message would be given priority on the given bus. So who decides that? Your CAN protocol will decide which frame to be considered. So it settles this collision between two or more frames sent onto the bus simultaneously. Okay. So now what is an identity? As you know, the unique individual characteristics by which a person or thing is recognized or known as, such as we have individual genes, every person have an individual PAN card number, telephone number. So this is what gives us identity. Similar to this, even CAN bus have an identity. So the bits present in the arbitration field, they can be arranged intelligently by the programmer so that each frame is easily distinguished by the unique sequence of bits present in this field. This is important. So this unique sequence of bits constitute an identity. So in this arbitration field, we can have a sequence of bits, and every bit every frame have a unique sequence which gives it identity. Thus, an identity facilitates the arbitration process with its unique pattern of zeros and ones, which we shall see in the coming slides a little further down in the presentation. So now Canvas 2A has an arbitration field that is 11 bits long, which can have 2048 different combinations. This means that with the 11-bit long identifier, there can be 2048 unique frames. So if we are using Canvas 2A, it means we can have 2048 different unique frames. So overall, there can be 2048 different frames. And these 2048 unique frames then can be sent onto the bus, and each of these frames can be easily identified by the nodes present on the bus. So how did we came to this 2048 number for 11 bits? Since we follow binary format and it consists of 0 and 1, with the help of this formula, we arrive at 2048. In the case of CAN bus 2B, it has an arbitration that is 29 bits long. So CAN bus 2A have 11-bit long arbitration and CAN 2B have 29-bit long arbitration. So this can have over 5 million different combinations. Okay. So this is a huge amount of data can be exchanged on the bus. This means that with a 29-bit long identifier, there can be over 5 million unique frames. And these 5 million unique frames can then be sent onto the bus, and each of these frames can then be easily identified and processed by different nodes present on the bus. So the bits present in arbitration field are carefully selected in the combination of zeros and ones that have to be decided by the programmer. So the sequence would be a combination of zeros and ones. As we know, 0 is dominant and recessive is 1. So usually the priority is given to dominant bits. So this sequence of bit will decide the priority level of different frames being sent onto the bus, and also acts as a unique identifier which helps a node to identify any frames present on the bus. So if we have two frame A and B and both are sent simultaneously on the bus, then if A have higher priority than B, then A will be given priority and the frame sent by A would be processed in the case of collision. So these bits, zeros and ones, they are selected intelligently by the programmer based on the priority. So this identity given to a frame is very carefully chosen. So from this point onwards, we'll be discussing on Canvas 2A as the 2048 unique identifiers. It provides us sufficient frames and it is sufficient for most of the application present in the world today.